This video is on solving linear models. Before we begin to look at linear models and set up equations and solve them, I need to make sure that you remember how to solve just a plain old equation that's already set up for you. So let's take a look back at some of the basics. First, I want to ask you, the opposite of addition, what is it? The opposite of addition, I hope you know, is subtraction. And what about the opposite of multiplication? I hope you said division. I'm calling these opposites, but the real name for this is inverse operations. And basically it's called that inverse because they undo each other, and we use that to solve equations. So anytime you see an equation, you want to look at it and say, what's happening to the x? And we want to get the x by itself. What's happening to it is that it's being multiplied. Remember, a number right next to a letter without any symbol there is multiplication. It's being multiplied by -4. All right, so what's the opposite of multiplication again? Division. And so we're going to divide by -4. What we do to one side, we have to do to the other. Now, a lot of students get a little mixed up about where to do this. So some of you that know that you have that problem, or even if you think you might want to take and draw a little line down the middle of the equation. That way you know that you always do something on one side of that line and the other side of that line. When you do that, -4 over -4 is 1, which leaves me 1x, or just x. Don't lose your equal sign. It stays wherever the line is. And if you'll notice here, this fraction can't be reduced. And if you're not sure, you should always put it in your calculator and check it. The negative, notice I moved to the top. We all just sort of agree it looks better on the top. You are allowed to do that. If there are two negatives, negative over negative, that's positive. Remember, negative divided by negative turns the whole thing positive. Not the case here, but something you need to know. Okay, so let's look at the next example. And this time, I want to get x by itself, and I see that there's a 23 plus x. So 23, it's positive. The opposite of a 23 being added to the x, just because it's in front, it's still being added, positive 23, is -23. But of course, what we do to one side, we do to the other. And this time I'm not dividing because I'm doing the opposite of adding, which is subtracting. 23 minus 23 is 0, and 0 plus x is just x. Don't lose your equal sign. Remember, this is subtraction. 47 minus 23, or 47 plus -23. You can do it in your calculator. You get 24. Now, both of these equations, and any equation for that matter, can be checked. If you remember, once you find out what x is, you can always check your work by plugging that number back in, by substituting it back in for the x in the original equation. Because when you do 23 plus, plug the 24 in there, 23 plus 24 is 47. If you don't get the right answer, it means you've done something wrong here. And maybe you just made a sign error. It's a good way to catch a little mistake like that. Okay, so the next two are two-step equations, and this is more likely what you'll see, so we need to make sure that you can do those. Do you remember what you used to help you remember how to simplify an expression? I hope you do. When you simplify an expression, we use a mnemonic that helps us to remember what order to do everything in. PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Well, to undo an equation, which is essentially what we do when we're solving an equation, when we're looking for the value of x, you do PEMDAS backwards. And it helps everyone to remember what order, because a lot of you look at this equation and you're not sure whether to divide by 2 or plus 3 first. And so this PEMDAS backwards can help you to know what to do first, because we will always do any addition and subtraction first, and we'll save the multiplication and division for the end. And so here we're going to draw our little separation where the equal sign is. We're going to plus 3 to both sides because that's the opposite of minus 3. We get 2x plus 0, which we don't need, is equal to 18. And now what's happening to the x? Keep your eye on the ball here. We want x by itself. To get it by itself, it's being multiplied by 2. The opposite is dividing by 2. And what we do to one side, we do to the other. 2 over 2 is 1x, or just x, equals 9. And again, you could plug that in to check your work. 2 times 9 is 18. Minus 3 is 15, just as it should be. If it doesn't come out, go check just that you maybe subtracted 3 when you were supposed to add it, or something simple, because most of the time it's a simple mistake and you can fix it. Pause the video and try this one on your own, and let's see how you do. All right, take a look. How did you do? I got x equals negative 1/4. There's a couple of things that could have gone wrong here, so make sure you look back at my steps. It was plus 8, so I subtracted 8 from both sides. That made the 8's go away. I had negative 4x equals 1. That's this line right here before I divided by negative 4. Since the x had a negative 4 directly in front of it, I divided by negative 4 on both sides. And when I did that, negative 4 over negative 4 canceled. That left the x by itself. And on this side, I have negative 1/4. All I did was move the negative to the top out of convenience. Okay, so I want to look at this problem. Let's just focus on the problem itself. The directions say define the variables and write an expression to represent each situation. So a farmer's market sells apples for 75 cents a pound and oranges for 89 cents a pound. Don't forget to use your highlighter and highlight the important information. Apples for 75 cents a pound, oranges 89 cents a pound. All right, we're going to write an expression to represent the total amount. So we're talking about the money now the farmer's market can earn selling apples and oranges. And I'm starting with an expression because we're not going to have an equal sign here. And I want you to understand that most of the problems you do will in fact require you to set this equal to something. But an expression means there's no equal sign. And I think you need practice doing that before you can set up and solve an equation. And so the first step is to name your variables. So we're going to call A the number of pounds of apples and B the number of pounds of oranges. Because isn't it true that if you knew how many pounds, you would multiply it by 75 cents? So there's the key. If you knew how many pounds, that right there is how you name your variables. Well, if I knew this, then I could figure it out. That's how you decide what your variables should be. And in this case, there's two different variables in this problem. Now, if you look at the expression that's written here, remember, no equal sign, expression, not equation. We have 75 cents times the number of pounds of apples. This first term is going to give us the total amount of money for selling apples. And then 89 cents times B, the second term is going to give us the total amount of money made by selling pounds of oranges. And so this is how you build an expression. Let's take a look at how we write an equation. So again, read the the question carefully, highlight the important information. I have carnations for $10.99 a dozen and lilies for $12.99 a dozen. There's a weekend sale and the goal, and this is important, is to earn $650. So if you think about what that means, then however much money, the total money we make on carnations and plus the total money we make on lilies, we want that to equal $650. So you have to get the idea of what you're doing first. And you might actually write in that the fact that it's and means plus here. Okay, so let's go ahead and name our variables. It's good to use letters that make sense in the context of the problem so you don't have to look back and see what X was and what Y was. C is carnations. It's never a good idea to use L because it looks like a 1, especially lowercase. So I think we just used F here for flowers just to be convenient. Now remember, if you take the price times however many dozen you have, you get the total amount of money made on carnations. And if you take the price times the total number of dozen lilies you have, that's the second term here, is the total amount made on lilies. And if we add those together, we know our goal equals $650. Now you're going to learn in the next unit actually how to do something with that, but we need to know how to set it up. And so that's what you're doing here. Let's read this next question. Pause the video, go ahead and think what you would highlight, what you would name your variables, and let's take it together. Okay, so the Basketball Booster Club, they're selling hamburgers. Let's see, hamburgers for $2.50 each, hot dogs for $1.50 each, and they hope to earn $900. So this is really like the last problem. They even wrote the equation, 250 times B, the number of hamburgers, plus 150 times H, the number of hot dogs, is equal to 900. So it's just what you would expect it to be, exactly like the last problem. Now they're asking you to use that to answer some questions. So let's take a look. The question says if they sell 315 hamburgers, how many hot dogs must they sell to reach their goal? So let's take a look. We've got the equation they gave us. Since we know the number of hamburgers, notice it gets plugged in right there, 315. When you do that, it gets multiplied because B was being multiplied to 250, and you end up with this equation, 787.50 plus $1.50 H is equal to 900. Now you have to do just what we practiced doing in the beginning of the video. All right, the numbers are big, but you know your calculator will handle that. And so when you minus 787.50 from both sides, you get this equation. And then when you divide both sides by $1.50, you get H is 75. Now what does that mean? Don't forget H was the hot dogs sold. H stood for how many hot dogs got sold. So if they sell 315 hamburgers, this tells us that they need to sell 75 hot dogs to reach their goal of $900. You're going to practice this more in class.